Now in this example, I want to calculate the magnitude and direction of the net electric force on Q2. Q1 here is 5 times 10 to the power of negative 6 Coulomb. And this one is negative, but it has the same electrical charge. 5 times 10 to the power of negative 6, but it's negative. This one is positive, which is 1.0 times 10 to the power of negative 6 Coulomb. So here we have the distance here to here is 4 meters, here to here is 4 meters, and here to here is 3 meters. So we have forces on Q2 due to the presence of Q1. That's going to be something like this. Q2 due to presence of Q1. And here, since there are unlike charges, we have attractive force F2 1. So I'm going to calculate it here. F2 1 is K times Q1 times Q2 divided by R squared. K is 8.99 times 10 to the power of 9. Q is 5 times 10 to the power of negative 6 times 1.0 times 10 to the power of negative 6. Divided by distance. Distance here, due to the Pythagorean theorem, I can say 3 squared plus 4 squared. 9 plus 16 is going to be 25. Square root of 25 is going to be 5. So R is 5, and same thing here. So it's going to be 5 squared. So F will be 1.798 times 10 to the power of negative 3 Newton. How to find out the components here? We have X components and we have Y components. We have F21X and F21Y. We have theta, and this one is theta. So how to find theta? We can say, we can use sine, cosine, or tan, doesn't matter. Sine theta equals to opposite divided by hypotenuse, which is 4 over 5. And cosine theta is adjacent divided by hypotenuse, which is 3 over 5. So that's going to be 0.8. This one is going to be 0.6. So F21x is F21 cosine theta, which is 1.798 times 10 to the power of negative 3 times cosine theta, which is 0.6. And we have F21y, F21 sine theta, equals to 1.798 times 10 to the power of negative 3 times 0.8. When we calculate it, that's going to be 0.103 Newton. Here we have 0.138 Newton. So these are going to be the X and Y components. We have the same thing for the attractive force here, this direction, and exactly the same thing in the going down. So as you see here, we have, let's call it F prime 21x and F prime 21y. These two are equal but in two opposite directions, so it means that the forces on the x-axis, they cancel out, so the net force is going to be 0. So the two remaining forces going down, both of them, so the net force is going to be added. So F net is going to be F21y plus F prime 21y, which both of them are exactly the same in terms of magnitude and also in terms of direction. 0.138 plus 0.138. So when you calculate it, it's going to make it 0.2 1.276. There was an error in the final answer here and here. This one was going to be 1.08 times 10 to the power of negative 3. And here, 1.44 times 10 to the power of negative 3 Newton. The rest is completely correct. They still cancel out. And here, it's going to be 1.44 times 10 to the power of negative 3 plus the same thing. And when you add them, it's going to give me 2.88 times 10 to the power of negative 3 Newton. So that's the net force, and it is going down. That's the direction of the net force.